One, two, three, one, two, three. Okay. Hello and welcome to the Beyond IoT 4.0 workshop 8.3. I am Manuel Caballero of Nimbus Research Center at MTU, and I will be moderating this workshop. The title of this workshop is Hardware Innovation Delivered. We have three wonderful speakers today with us who will tell us all the info we need regarding this topic. The format of the workshop will be a slideshow followed by a Q&A session. Please step back throughout the workshop by typing your questions into the chat area. The speakers will answer those questions at the end of the workshop. Please note that this workshop will be recorded. And now we are ready for rock and roll. I think we're going to have fun. I am pleased to welcome our next speaker with myself.
Welcome.
So let's go there. And the presentation. There you go. So the hardware innovation delivered is the topic. This presentation is meant to show the main issues and the ways to solve them when it comes to a hardware project. I'm Manuel Caballero, a senior researcher at Nimbus Center. My skills are hardware and firmware design mostly, although I moved into microelectronics design and application of nanoscale systems. And in this presentation, I'm going to be totally fair with you. I want to go straight to the point. So, when is a project successful? I would say, according to my experience, when a project provides margin. In other words, when the budget covers the whole project, when it mitigates risk from defects, and when it satisfies the customer. That sounds terrific, but it's very generic at the end. So let's go a bit in depth. When do things go wrong? I think this is the heart of the matter at the end. Okay. And things go wrong when poor interaction between the electrical design and mechanical design. Sometimes the communication between the teams in a company and the client is not fluent. Poor understanding of supplier limitation. This is very, very, very useful and very important. And this is related to the previous one, kind of. And let me give you an example. The client sometimes considers that the smaller the device to be designed is, the better. But that's not true. In fact, in most of the cases, that's totally false. As an example, I'm going to continue with the example. If the device to design is small, that means that the printed circuit board, the PCB itself, must be small too. Therefore, the hardware design will be more complex, increasing the total cost of the project at the end. And for those smaller components, maybe they may not be in stock. So that provokes that the project is delayed. Yeah. And when life was different without lockdowns, restriction because of a virus, I don't know if you remember that life, I mean, I miss it. And people could meet. I remember on one of the conferences I attended, a speaker said the following sentence. There can be many things that you don't know. And believe it or not, that sentence was like a revelation. That sentence makes a lot of sense to me for both the client who has the idea and company that has to implement that idea. That's why a very good understanding of what it is going to be designed is mandatory to minimize the unpredictable and unknown things that may arise during the project. And before I leave the bad things, what it may go wrong in a project, let me show you a graph that summarizes what we have seen so far. By the way, I didn't make this graph. I got it from the DFR Solution Company on a workshop that I attended, but I think it makes a lot of sense. It shows the cost in terms of reliability. Generally speaking, if we split the project into 4 phases, like concept, design, validation, and production, we can analyze that cost. For the concept side, is the idea itself. So the reliability is not that important in this phase. Here, the communication between the client and the company is the key. Then for the design phase, if something goes wrong, the cost increases because there are tasks that have to be redone again. And then we have validation and production, where the cost of unreliability is huge. Why? Basically, because some tasks have to be made from scratch, and the customers of the client may end up losing faith on the product. So the big question, what can we do then? Well, as I said previously, a good communication between the client and the company is the key. And guys, I'm not gonna get tired of repeating this sentence, this mantra. Communication is the key. So on the other hand, on the company side, the deliverable has to be optimized in terms of the initial funding. Then you may think, Manuel, this is just a matter of money at the end. Okay, the answer is no. The funding is important, but a good organization is mandatory. That's why here at Nimbus, we pay a lot of attention to this subject. We compact the idea and expectation of the client with the initial funding using the technology readiness levels, TRL at the end. So therefore, depending on the idea of the client and the sort of funding, we find the optimus TRL for the project and what has to be delivered. So finally, as a conclusion, here are weapons, the engineers and Nimbus Center, to deliver a successful project are: we try to make use of industry standards as much as possible. Doesn't matter if it's for hardware design or firmware design. We pay attention to those little details like the mechanical, aesthetics, and thermal are just as important as electrical. Design rules are a good start, but not the way to win. Here I repeat myself, the communication in the company between all the departments and the client has to flow. That's the key, the communication. And finally, assure that critical objectives of cost, quality, reliability, safety, time to market, and customer satisfaction are known, balanced, monitored, and achieved with correct funding. That's why here at Nimbus Center, we try, or we take care of the whole process, from the idea to the final product. And that's pretty much what I had to say. So thank you for watching. Don't leave it. And if you want to contact me, this is my email, manuel.caballero@cit.ie. So, okay, so that was my presentation. Now we're gonna move on to our next speaker, Mr. Nicolas Chaliquias. How are you doing, Nico?
Hello, Manuel.
Good. So I'm gonna introduce you to our attendance. Mr. Nicolas Chaliquias, for the last 30 years, has developed embedded systems on telecom, industrial, and wireless sensors, involved in proposals and full development life cycle from board to system level, procurement, production, and testing. Here at Nimbus, in the NTU, he's leading the development of embedded system and end-to-end IoT project. He's the leader as well of the MBlocks project, which is a modular embedded system platform, and the MBlocks Studio. Did I miss something?
No. Perfect.
So let me share your screen now. Hold on a second, because one second. Okay. I'm gonna share now this one. Share go here. 5 share.
Manuel, could you share the single slide screen? Yes, this one.
Okay. So when you're ready,
I'm ready. Okay, it's about MBlocks and MBlocks Studio. Next one, please. NBlocks is an IoT development platform for hardware and firmware we have created in Nimbus Center to support our clients' innovation projects and to spin out a commercial entity. Third, please. NBlocks is a modular, low-power embedded system platform based on a standardized pin-out and form factor. NBlocks adopts the plug-and-play concept where computing, sensor, power, and communication boards can be plugged together capability. Some metrics: 60 different NBlocks 24 pins, 16 NBlocks Pro, 7 years in 35 projects, 40% less development time, 125 firmware libraries, 40 wiki articles, and 3 publications. Number 4, please. NBlocks has been used in many projects for European Union, industry, agriculture, lab automation, water management, and more. A sample of them: fats, oils, and greases monitor, wireless building management, river environmental monitoring, cat nutrition injector. Okay, what happens here? And modular lab rig controller. Okay, next one, please. The NBlocks platform. This is about NBlocks Pro, the newest series. Is built with the following principles in mind: modularity, boards that can be plugged together like bricks to create wireless nodes or controllers with varying capabilities. Functional scalability, boards have 240 pins to expose as many functions as possible and create a non-limited scalable platform. The processing performance scalability, a large range of ARM Cortex microcontrollers, support a wide range of software applications starting from battery power sensors to Linux on the edge. Ultra-low power operation supports unattended and battery-operated IoT devices. Number 6, please. The modularity, host and peripheral boards plugged together to implement the use case and no cables are needed. Many IoT use cases can be delivered by plugging just 2 boards. The host boards, they do have a microcontroller, and they all have a common pinout, 240 pins in 4 low-profile connectors. Ultra-low power and wireless is also supported by the host boards. Peripheral boards have no microcontroller, can be ultra-low power sensing, application-specific motherboards, display, actuators, motor control, and more. Development board support includes piece breakout and prototyping, embed enabling and debugging, ultra-low power. Number 7, please. Our half-size NBlocks Pro supports sensor expansion, small microcontrollers, and adapters to be used with low pin count applications. Number 8, please. This is an example of a feature-rich ultra-low power battery-operated LoRaWAN sensor. 3 boards, a battery holder, and an enclosure are integrated without cables or any soldering. This example is a wireless battery-operated LoRaWAN environmental sensor reporting to our NBlocks dashboard via the TTN and NL-compatible gateway. Yes, we can go to the next. This is another example of a motion controller that can be used on 3D printers, CNCs, and robots. Here is controlling an experimental motion control system for 3D printing and pick and place. The red brick is an ARM Cortex M3 NBlocks Pro host driving the system, and the motherboard is an application-specific NBlocks Pro peripheral. Number 10, please. One more example on using N-blocks. This is a motherboard for lab automation projects with a 24 pins series. The white peripheral boards can be controlled by serial channel, like I2C, SPI, or UART from the microcontroller N-block. And the distributed functionality of the white boards can be thermistors, load cell, DC motor control, power PWM outputs, digital inputs, analog outputs, proximity, or Modbus. Number 11, please. In this example, we are using a development support N-block, which provides embedded enable and debugging interface over serial over USB. This board can be sandwiched between two other boards to provide debugging support while this is needed. And then it can be removed so the debugging capability is not an overhead. Number 12, please. Okay, we jump to our software development tool. N-block Studio is a development tool to produce embedded software using the flow-based approach. It is mainly focused on developing firmware to run in the microprocessor powered N-blocks, enabling fast, intuitive application development for the Internet of Things. Furthermore, it was developed having in mind the compatibility with other scenarios, becoming a general purpose embedded firmware development tool. Due to the flow-based strategy, users can develop a full working application without code, as a large part of the writing effort is replaced by graphical connections. N-block Studio features a graphical diagrammatic programming environment for application development. Its aim is to allow users to develop applications without writing code. It uses a flow-based design paradigm where function blocks are connected with wires. About the code, the N-block Studio generated code runs in a soft real-time firmware system, and there is an underlying kernel and event-driven tasks. Finally, about the server, the N-block Studio public server manages nodes written by the N-blocks team, as well as by the users, contribute and share nodes with the N-blocks user community. The basics, the concepts, the node, a node is the basic building element of the design. The nodes are event-driven and create outputs in a timely manner, driven by the periodic kernel operation. The node's inputs in the graphical environment are on the left, and the outputs on the right side of the node. Flow is a single set of connected nodes, like this one. Connections connect the nodes and represent how events flow through the nodes. In the graphical environment appear as wires, like this one. Design is the total of the nodes used to implement a working system. Translation is the process of the automatic code generation from the design files, and compilation is the creation of the executable files we program to our board. Number 14, please. The design workflow for a schematic design project. First, we select the nodes. Then we create a design by placing all the nodes on the canvas, connecting them with wires, and configuring the nodes parameters. Third, we call the N-block Studio translator. The C++ project folder tree is created and populated with the libraries and the auto-generated code. Fourth, we compile with our normal compiler. And finally, we flash program our microcontroller and we have a working system. Number 15, please. One example, N-block Studio supports multi-board design. That is the creation of the firmware of all different boards of a system in a single design sheet. In this example, we have both the transmitter and the receiver of a LoRa radio testing setup. 16, please. A little bit about the kernel. The mBlox Studio kernel is a low-footprint, soft real-time kernel with low dependencies, manages the flow-based, timely execution of Node's code. The Node's code execution and the messages flow are both controlled by the kernel. Number 17. The mBlox Studio server runs on a public hosting service, and the users are registered, can contribute with nodes definition, and use existing nodes created by other users. A small example here, we have a user named A who has contributed 12 nodes and is using 36 nodes from the total of 60 available. Number 17. Each node code is maintained in its own remote Git repository, supporting autonomous node evolution and documentation, maintenance of legacy programs that are using past versions of the code, and privacy if needed for IP protection. The Git repository can be hosted securely in the cloud or even in on-premises Git server. Number 19, please. Yes. The hardware-related nodes code is using the ARM-supported Mbed hardware abstraction layer. The Mbed HAL allows faster node code development with well-supported variety of features for a large range of microcontrollers. mBlox Studio is tested with mBlox and third-party ARM Cortex boards. Arduino. The support for Arduino hardware layer abstraction is a new feature in testing status. The Arduino compatible mBlox Studio kernel and the nodes are tested with a standard 8-bit Arduino Uno. And the last one, please. So, working with mBlox Studio, it only slightly affects the project file tree structure, adds a high-level design element, dramatically reduces manually created code, reduces development time, and facilitates library and IP maintenance. One more. You can communicate with me, and I'm finished.
Okay. Thank you, Nikos, for the presentation. Now, before the question will be answered at the end of the workshop. So now we're going to move on to our next speaker, Dave O'Toole. Hey, Dave, how are you doing? You're mute. You're mute. There you go.
You okay there?
I'm okay here.
Can you hear me?
A bit stressed, but I'm okay. So let me introduce you. So Dave O'Toole, he owns a locksmith business. He's in the locksmith business for 40 years. He's the CEO of Touch to Access. He is currently president of the European Locksmith Federation and European ambassador with the Associated Locksmith of America. Am I okay?
You're good, Manuel, yeah.
Yeah. I think you want to show a video first, right?
Yes, please.
So let me do this first. Then share. And 5. Share. Yep. Sorry. Let me do something first.
Have you heard of Touch Access Lock and access control readers? Whether you are a senior citizen or have a disability that has trouble with keys, a busy parent with your hands full, or perhaps just looking for an easy, secure way to access your home or office, Touch2 Access has that answer. With just your key card in your pocket, our patented touch technology allows you to simply touch the door and a signal travels from your key card to the lock and unlocks it. Check touch2access.com today to find out more.
Okay, Dave.
Okay, Manuel, thank you very much. Thank you. Hello, my name is Dave O'Toole, and I want to share my experience in getting my product to market with Nimbus, Enterprise Ireland, and Arrow Electronics. I am probably like some of you. I had a business idea, not sure how to develop and manufacture, worried about financing it, and how to get to market as quickly as possible. I learned that it's a long road, but there are plenty of opportunities for help along the way. There are many people and organizations willing to help you on your journey. You just have to identify who they are and get them to help you. I own Expert Security, a small locksmith business in Dublin. I've been in the lock business for 40 years. The company installs, repairs, opens all types of locks. I have a shop that makes security keys, key fobs, and remotes, and sells locks and electronic security. Several years ago, my mum suffered a stroke and could not use keys or codes to open her door. As a locksmith, I wanted to do something to help her and millions like her around the world with the same problem. I developed and patented an electronic touch lock for the elderly to open their doors easily, but did not have the expertise to carry it on. I had the technology, but I still had to get a product to market that was going to cost me a lot of energy and money. I knew what I wanted, but how to achieve it with my limited resources and experience was the big problem that I faced. I had already invested €100,000 in developments and patents. I attended the annual manufacturing show in City West in Dublin and visited the Enterprise Ireland stand. They were showcasing their gateway partners. I saw that Nimbus was their technology partner. I had already heard of Nimbus and the Cork Institute of Technology, and I knew of projects that they were working on. I contacted Nimbus and travelled down to Cork to meet with the director, Richard Linger. We discussed my idea, the technical challenges, and how Nimbus could develop it for me with the help of Enterprise Ireland grants. He believed that Nimbus could help me get my lock to market. Richard introduced me to one of the chief engineers, Juan, who was very enthusiastic about my idea and the possibilities for it. Juan spent some time with me discussing the challenges that lay ahead with developing the technology and also the funding process. There and then I knew that I was in the right place with the right people. We decided that the best way to proceed was to avail of innovation vouchers from Enterprise Ireland. Nimbus organised 2 vouchers worth €10,000 for a feasibility study. They did all the application work and filled out all the forms. All I had to do was to sign the application. We met with an Enterprise Ireland engineer who evaluated and approved our technology and grant. Juan made improvements to my technology and wrote up a new patent which extended the capabilities of the existing patent, which used my RFID touch technology into low-frequency radio waves, including Bluetooth, which gave us new opportunities. Nimbus then introduced me to a patent lawyer, Michael Lucy, based here in Dublin. He advised and amended the application and filed it on my behalf at a very reasonable cost. We completed the feasibility with our innovation vouchers, but needed more funding for the developments. We applied for the Innovation 80-20 partnership with Enterprise Ireland for €80,000. I had to provide 20% or 16,000 of this grant that we were applying for. We calculated that 80,000 would cover the costs of completing the development with prototypes and doing field testing, as well as commercializing and evaluation. Another positive thing about Nimbus was that Ronan and Brian in the commercial department advised me and filled out all the applications forms for Enterprise Ireland. I had heard all about completing Enterprise Ireland application forms and business plans from other entrepreneurs. which I was dreading having to do, but thankfully they did it all for me. We still had to get the innovation partnership approved by Enterprise Ireland. We were interviewed by their engineers who had to approve the concept. They met with me and Juan separately. It took a little time to get approved, but we got it. Not only was I getting technical development from Juan, his team and Nimbus, but I was getting Kevin O'Mahony and his team who would help me with identifying markets and the certification needed. Once we got the funding, Juan, Kevin and me sat down to agree on the commercial possibilities. The two lads had great experience and came up with some great new ideas for touch technology. They showed me that I had more than just a lock. They introduced me to the world of IoT and artificial intelligence and how to implement my technology by integrating touch in smartphones. I now had a clear vision as to how I would proceed. I had a clear map to manufacture the touch lock when COVID hit the world. Suddenly I had a serious problem. I had a technology and product that was activated by touch, which had negative connotations. I knew that we had to pivot away from our touch application. The country was in lockdown, but the engineers in Nimbus, although working remotely, continued relentlessly with my project to overcome this problem. We went back to Enterprise Ireland, who understood the problem that COVID had caused us, but also the new opportunities that presented itself. We got more funding from them to redevelop. Juan and his team, include Manuel, Andrew and Robert, engineered the touch technology to deliver a contactless solution. Now users with a tag in their pocket just had to present their hand in front of a panel beside the door and our smart lock would open automatically. The lock could be opened with a phone app too. Not only did we create a contactless door lock, we developed a technology to operate any electronic device without touching it. Using our patented and proprietary tag in the pocket or with a phone app, we could now safely, securely and conveniently operate access control readers, door operators, alarms, elevators, computers, office and industrial equipment and even cars in a new COVID world. All these can be opened with one tag that be programmed as to who and when can do it. The final piece of the jigsaw was for Juan, his team, and Arrow Electronics to source the electronic and plastic components at competitive prices. They did this with all the schematics for manufacturing. They introduced me to a small electronic manufacturing company who would do small runs for me at a competitive price. The research project with Nimbus is nearly complete. The prototypes are ready to go into production. We are finalizing a website funded by a local enterprise voucher to sell locks online worldwide. We will focus on the healthcare market in UK, Germany, and US. I had access to Enterprise Ireland's reference library, which I was able to do a lot of market research. Looking back, I would have found the whole process overwhelming if I had tried to do it on my own and most probably would not have succeeded. With the expertise of Nimbus and the support of Enterprise Ireland, my idea to help disabled people all around the world to open their doors easy is becoming a reality. Thank you all for joining with me, and I hope there was some help for you. And I wish you every success in the future. Manuel, if you could just finish with the demonstration video of the products where we are now at the moment.
Yeah, on this way. Give me a second.
Have you?
Hello, my name is Dave O'Toole. I am a locksmith from Dublin, Ireland. When my mum suffered a stroke, she could not use keys, codes or phone to open her door. To help her and millions like her around the world, I developed and patented the Touch Lock, the most convenient and secure door lock on the market for simple door access. When COVID-19 hit, we developed a contactless door lock and a frictionless access control reader. With an ID tag in the pocket, a purse or around the body, a user presents their hand to a pad on the door and the lock opens automatically. This has sent a signal to a motorized lock. and without the need to carry a phone like other smart locks. We have a US deadbolt too, and although an ID tag user does not need to carry a phone to open the lock, there is an option for users to have an app to open the lock. Our ID pad, tag and app operates Bluetooth security systems, electronic handles, padlocks and safes. We have developed a 12-volt frictionless access control reader and electronic switch for commercial buildings using our contactless technology. The reader can integrate with OEM locks, door operators, security systems, elevators, cars, electronic equipment and computers for secure and contactless operation with open or OEM proprietary protocols.
Thank you, Dave, for your presentation. You're on mute, sorry.
Okay.
Thank you for your presentation. And now it's turn for the Q&A. So we have a question from Nick. It's for Nikos. Actually, there are two questions. The first one is, Nikos, are you there? Nikos, you are?
Yes, okay.
Okay, so the first question is mBlocks intended for industrial design, fast prototyping development, or more hobby student focused?
It's more intended for industrial fast prototyping because this is how we develop it and how we use it. I don't see any object to using this, but our mentality was to help ourselves, and we were designing for industry.
Okay. The second question is there licensing or IP ownership associated with mBlocks?
We are commercializing this project, so the intention is to create a spin-out. The spin-out will get all the IP. I think the question could be a little bit different. Can anybody use it right now and have some results? Yes, it can, but I don't know how we manage the IP for that.
If there no more questions, so we're going to conclude now. We're going to wrap up the session. To conclude, I would like to thank all our speakers and contributors. You can check out the other workshops taking place at Beyond IoT on the event website, beyondiot.ie. And just to remind you that you can also visit the main stage and research stage at any point. Thank you for attending this workshop at Beyond IoT, and I hope you have enjoyed as much as I did. So see you next time.
Thank you, Manuel.